Hey everyone, and welcome back to section 7.1. Last time we talked about simplifying rational expressions, which is going to come in super handy when we talk about multiplying and dividing rational expressions. Let's start again with a recap. For multiplying and dividing fractions, we know that that's kind of the easier operations to do because we don't need a common denominator. So to multiply fractions, you just multiply the numerators and denominators together, and then simplify. Multiplying and dividing rational expressions is going to work the exact same way. So let's look at an example. We just multiply straight across, so the numerator times the denominator. Now, you do not want to multiply all this stuff out until you know that your fraction, that you've canceled out any common factors in the numerator and denominator. So we got to factor the numerator and denominator fully, and you can actually do that as the first step, which we'll see in a different example. But the numerator is going to have a factor of 2x, and then we also have x squared minus 9, difference of two squares. Super duper easy. I'm going to put that 6x over here so I don't lose track of it. Now I need to factor that x squared minus 7x plus 12. So I'll have an x and an x. And I have a positive here, so my numbers are the same sign. They got to multiply to 12 and add to 7. 3 and 4. Both of them guys are minus signs. And hey, wouldn't you know, this factor of x minus 3 divides out. But that's not all, right? The 2 over 6 divides to, or reduces to 1 over 3. And in fact, this factor of x here divides out. So upstairs, all we have left is x plus 3. And downstairs, we just have x times x minus 4. And it doesn't have any common factors left, so we are done simplifying. There's our answer. All right, let's try again. So this time, what I'm going to do is factor everything completely before multiplying. Right, so I've got some pesky polynomials that don't have a coefficient of 1 by the a squared, so those are a little bit more labor intensive. All right, I got to do that AC business, so I need m times n to equal 9, and the middle sign is negative, so m minus n in absolute value should be equal to 8. Oh, and 9 minus 1 is 8, so m and n as 9 and 1 would work. Okay. So I have 3a squared. Since it's negative, it's going to be the 9 that has the minus sign. 1a would just be a, minus 3. Factor it by grouping. That second group really doesn't have anything in common, does it? So it's just going to stay as is. The first group can pull out a 3a. So I can factor this a minus 3 out. I get 3a plus 1. So remember, we're thinking of factoring like dividing. And we get 3a plus 1 times a minus 3. That was one of 4 polynomials factored. Yippee. Let's look at the next one. I need m times n to equal 3 times 5, which is 15. And middle sign's negative, second sign's negative, So in absolute value, their difference should be 14. So factors of 15 that would work would be 15 and 1. The 14 is negative, so the larger absolute value should be negative. This is like the last one. You can factor out a 3a, get a minus 5 plus a minus 5. So factors to 3a plus 1 times a minus 5. So which one is that? Oh, it's this one. All right, these other ones are a little bit easier to do. So we have a difference of squares in the lower left. And in the top right, let's see, how am I going to factor that guy? Oh, this is, that guy's a square. It's 5 squared. And this is 2 times 5 times a. So actually, these are both the same. Now what we can do is do some dividing. So this 3a plus 1 factor is going to divide out. What else is going to divide out? The a plus 5 factor. Okay, then what we end up with is equal to a minus 3 times a plus 5 over a minus 5 squared. So we've done a lot of multiplying. Let's do some dividing now. Remember that when we divide by a fraction, we're multiplying by its reciprocal, actually. A over b divided by c over d is really saying a over b times d over c. For an example, we have this guy here. It works the same way as with dividing rational numbers. This would be p squared plus q squared over 2p squared plus 4pq plus 2q squared times the reciprocal of that second fraction. Let's factor. So I know the numerator of the first guy doesn't factor because it's the sum of 2 squares. That stays as is. And there's a GCF of 2 in the denominator of the first. 6 is just whatever, it's just 6. P squared minus Q squared, difference of squares. Kind of running out of room. There we go. Oh, and we can further factor the denominator of the first rational expression. It's one of those special forms, P plus Q quantity squared. And then we just multiply. I know that the 2 and the 6 they're gonna reduce, but I don't see anything else that does. So I'm just gonna multiply. Since P plus Q is acting like a base in this case, we would actually add an exponent from this guy over here. Oh yeah, this 6 would reduce to a 3, wouldn't it? So we'd actually have 3 times that, and P minus Q. And that's it. It's kind of a bummer because it doesn't really simplify anymore, but it's important to recognize that it doesn't because you have the sum of 2 squares, which doesn't factor. I know you feel like a really strong temptation to do some, let's say, less than reputable algebra moves, but you want to resist that temptation. So the answer that we're left with is kind of ugly, but you know, it's fine. Ugly expressions are expressions too. Okay, they're perfectly valid as expressions. You know, they're maybe they have a nice personality, maybe they're really funny. Am I projecting? Next example. here, oh goodness. So here what we have is fractions in fractions, but those fractions are polynomials, so actually it's even worse than we thought it was. But remember, we treat fractions like division. So I'm taking this top rational expression and I'm dividing by this bottom one. And as before, when I divide by a fraction, I'm actually multiplying by its reciprocal. And then you want to factor everything before you multiply it all together. On the top left, I have a difference of squares, which is always good. Top right, I have 4 times 2y minus 1. That's a pretty easy one. Bottom right, I have 2 times y squared minus y minus 30, which I can factor further. And 2y squared plus 11y minus 6. So we have to do our AC, but I'll do that very quickly. Alright, yeah, so back to reality now. That guy factors as 2y minus 1 times y plus 6. Now let's see if we can cancel anything. Now some people don't like that word, cancel. But it's kind of a colloquial thing, so I guess the proper thing to say is dividing to 1. I have a 2y minus 1 there. Oh, but before I do that, I need to factor that last bit. But actually, while I'm at it, this is gonna reduce. Let's see, what divides out? 2y minus 1s, these y plus 6s, this y minus 6. Oh, and so actually we end up with something that is not so terrible, 2 over y plus 5. So again, this started out really ugly, but we actually brought out the expression's inner beauty. So we have 2 over y plus 5, very, very simple. Last example, you can combine all these things in tandem. You don't have to just multiply two rational expressions. You can multiply a finite number of them together and still figure out what rational expression you get. So we're going to start working on here. We're going to start working on this guy here. All right, so the division, just so we're all on the same page, I'm going to flip that fraction and turn it into multiplication. That third fraction, I mean. Okay, so let's factor. First fraction, GCF of 3, so x minus 2. GCF of 4 on the bottom, x minus 1. Middle fraction. Okay, so it has to multiply to give me 3, so there's not terribly many things that do that. 3 has to be positive, because the middle term is positive. Alright, now bottom, 2 things that multiply to give me 10, but their difference is 3. 5 and 2, that'll work. This time 5 is negative, and 2 is positive. And what else do we have? Oh, we have a GCF of 8 over here. And a GCF of 2. Okay. Let's start reducing everything. So x plus 2s, those are going to reduce to 1. X minus 1. And Let's see. Oh, and then there's this 4 and this 2, which would multiply to give me 8. So that reduces that 8 there. I don't see anything else. So we end up 3 times x minus 2 times x plus 3 over x minus 5 times x plus 6. So I think I'm going to call that good on multiplying and dividing rational expressions. If you liked that, then you will surely be excited about adding and subtracting them. We need to find a common denominator. Look forward to it.